Hi guys, so we virtually made it to the end of Unit 8 finally, which is awesome. So this is your Unit 8 recap. So Unit 8 was all about solving quadratic equations. Unit 8, we focused on developing techniques to solve quadratic equations. So we should remind ourselves, what's a quadratic? What's a quadratic equation? And a quadratic equation is anybody that has an x squared term. So where the highest power, the degree, they're degree 2 polynomials. Remember, degree means the highest power. So any equation that we call quadratic has that x squared as the leading term. You should probably take these notes somewhere in your pink book somewhere just to keep them, or you can do them on separate paper. But this is just for you to take notes, absorb, and practice and say, oh yeah, I know how to do that, or oh, I need to go over that again. So we can solve quadratic equations, and we came up with three different methods. The first one was our favorite property, the zero product property, the ZPP. So we have the zero product property. That's method one. And what goes hand in hand with the ZPP is factoring. You have to be able to factor to use the zero product property. Our second choice was to use completing the square. We complete the square. And what goes hand in hand with that is inverse operations, being able to undo things using square roots. And finally, our third solution, our third option for solving a quadratic equation is our favorite, the quad formula. So we can solve a quadratic equation any of these ways. We can factor, use inverse operations, or use the quadratic formula. So the zero product property only works if you have rational answers. It doesn't always work. It only works if you have nice fractional numbers as your answer. -4, 5, 1/2, 2/3, any nice fraction. These guys, these two always work. These, completing the square and quad formula, always work. These work for rational and irrational solutions. These work for both rational and irrational solutions. So factoring is quick. Completing the square is really quick for irrational ones if you have a middle value that's even. And quadratic formula always works. The quadratic formula will tackle any problem, any quadratic equation that we need to solve. So the key thing, regardless of what method we do, we need to make sure it's set equal to 0. Whenever we solve quadratic equations, we set them equal to 0, regardless of what technique we're going to use. So it should look like ax squared plus bx plus c. When we complete the square, we like that b value to be even, and you have to have a plain old x squared. You have to have a plain x squared. You need a leading coefficient of 1. If you don't have an even b value, or you have like 2x squared or 3x squared, jump over to the quad formula. It's going to be a lot cleaner than doing completing the square. So completing the square always works. It can get messy, which is why we came up with the quadratic formula. So right now, I'm going to walk you through one of each of these problems. I'm going to walk you through factoring, completing the square, and the quadratic formula. I might do the same problem a couple different ways, but I want to show you that we can use these techniques to solve quadratic equations. So we'll start off by looking at the quadratic equation, 2x squared minus 3x minus 20 equals 0. So the first thing I'm going to look at, I'm going to say, okay, that's great. It's set equal to 0. So now I need to come up with some kind of way to solve it. And I want to practice factoring. So let's try factoring this. So quick review. This is important review for a lot of us. How do we factor a trinomial? Well, we factor a trinomial by making a box. So this first technique I'm going to use here is by factoring. Let me write that. By factoring. So I'm going to make a table. And in that table goes the first term and the constant term. And then we ask ourselves two questions. We say, self, hopefully you said self with me there. What multiplies to 2 times negative 20? What multiplies to the product of the leading coefficient and the constant that adds to my middle term? Because I want to add to that middle man because those two boxes need to make up that middle term. So I need to think or use my calculator. I need to think, and that's the problem with factoring is it actually requires thinking. What multiplies to negative 40 that adds to negative 3? What multiplies to negative 40 that adds to negative 3? Well, I'm thinking it's negative 8 and positive 5. So negative 8x and 5x split up that middleman. These two boxes split that middle term there. And now we factor out from the side. 2 and 8, I'm going to take out a 2x. X minus 4, negative 4 times 2 is negative 8, plus 5. 5 times x is 5x. So I know my factors. I know my factors are x minus 4 and 2x plus 5 equals 0. So now I can apply the zero product property. If two things multiply together and make 0, one of these two things is 0. That factor is 0, or this factor is 0. So I get x equals 4, or I got to do a little bit more work over here. 2x is negative 5, so x equals negative 5 halves. Notice I got rational answers because I was able to factor it. So you have to remember how to factor trinomials because all of this good stuff that we're doing right now is coming back into Unit 9 when we get there. So that was factoring. Completing the square is a terrible option for this. So I'm going to show you that I could have also used the quadratic formula. For the same problem, I can use the quadratic formula. I've got a equals 2, b equals negative 3, and c equals negative 20. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I plugged into the quadratic formula there that hopefully you're singing along with me. And now I need to type in what's under the radical. I need to type in what's under the radical. In parentheses, negative 3 squared. Look what I typed in there. Yours should look just like that. Minus 4a. C, had to sneeze there, sorry. And that's what's under the radical is 169. So x equals 3 plus or minus the square root of 169 all over 4. But wait a minute. Sometimes you get a perfect square here. The square, what times itself is 169? Sometimes it's obvious, sometimes it's not. It happens to be 13. I saw 3 and said 13. I saw 3, I meant to say 13. Moving on. 3 plus or minus 13 over 4. So now I can split it. 3 plus 13 is 16, which equals 4. 3 minus 13 is negative 10. Well, negative 10 over 4 is negative 5 halves. And what do you know? We got the same answer whether we factored or used the quadratic formula. That's the beautiful thing about all these quadratic equation solving techniques. We're building tools, or we're building a toolbox here to solve these equations. We have multiple options to solve them. And I wanted you to see that regardless of what technique we use, we end up with the same solution. All right, sliding on down. Let's look at this new equation, x squared plus 6x equals 3. I'm going to solve this one 2 different ways for you, and then we'll call it a video, and then I'll let you guys do some good work. So I have a problem that it's not equal to 0, so let's fix that. X squared plus 6x minus 3 is 0. I could try factoring, but quickly looking at this, what multiplies to 3 and adds to 6 is nothing. So the first thing I'm going to do for you here is I'm going to complete the square. That's the first technique I'm going to use. So that's where we look at the first 2 terms and we cut the middle man in half. We cut that middle term in half to complete the square. The magic number that completes my galaxy square here is 3 times 3 is 9. So what do I do with that 9? Well, I stick it into the equation, x squared plus 6x plus 9. I just put it there. But I can't just add 9, so I have to counteract it with a minus 9 on the outside. So I kind of just wedge it right in there. Minus 3 equals 0. Then we factor this, x plus 3 squared. How did I factor this real fast? Well, look at the box we already made. X plus 3 times x plus 3 is x plus 3 squared. Minus 12 equals 0. So that's step 1. That was using completing the square. Now I'm going to use inverse operations to get x by itself. So I'm going to add the 12 over. X plus 3 squared equals 12. I undo squaring with the square root. X plus 3 equals plus or minus the square root of 12. Remember, when you take the square root, you have to include that plus or minus in front of it. And then finally, I'm going to subtract away the 3. Negative 3 plus or minus the square root of 12. Now, that's basically the answer, but if I go over here to Scrapland, isn't 12 4 times 3? So it's really 2 square roots of 3. My final answer is x equals negative 3 plus 2 square roots of 3, or x equals negative 3 minus 2 square roots of 3. Those are my two answers. Now, I could check it in my calculator for decimal versions. If I ask you to round to the nearest tenth or round to the nearest hundredth, I can type these in to get decimals. Negative 3 plus 2 square roots of 3. Actually, I didn't even have to simplify it. I could have done negative 3 plus the square root of 12. If I ask for decimals, there's no need to simplify the radical because you're going to get the same thing. So it's about 0.4641, blah, 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 blah. So this is 0.4641, blah, 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 blah. And the other one is negative 3 minus the square root of 12. Negative 6 point, blah, 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 blah. So we get negative 6.4641, blah, 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 blah. I got irrational solutions because I knew I couldn't factor it. When I tried factoring it there, it quickly in my head, it didn't work. So completing the square was a good choice here because it had an even middleman and started with a plain old x squared. So these are exact solutions. These are decimals. These are rounded. Well, I didn't round them, but I would say round to the nearest tenth, round to the nearest hundredth. To have you chop it off to give me nice crazy decimals. Or I could have completed the square. Or I just did completing the square, or I could have used the quadratic formula. There you go, Heinz, you got this here. Quadratic formula goes A is 1, B is 6, C is negative 3. Now I should be getting the exact same solutions here. So here we go. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times 1, which is 2. So once you plug into the quad formula, you type in what's under the radical there. 6 squared minus 4 times a times c is 48. Is 48. So x equals negative 6 plus or minus the square root of 48 all over, make sure that it's a big fraction bar, 2. Whenever you do the quadratic formula, so if I said decimals at this point, type this into your calculator and you'll land up there. But I won't say that all the time. Sometimes I'm going to have you break down the radical. How do I split up radical 48? Radical 48 gets split up as, well, 4 works. But wait, I can break that up even more. So there's a bigger one, 16 times 3. So 4 radical 3 is what gets replaced there. So x equals negative 6 over 2 plus or minus 4 radical 3 over 2. I split up that fraction. Everybody is over 2. So I get x equals negative 3 plus or minus 4 divided by 2 is 2. 2 radical 3. What do you know? I got the exact same darn answers because I solved the same equation just using a different technique. So there you go. That was the big idea of Unit 8. Unit 8 was all about these quadratic equations and the 3 different techniques we have. We can use factoring, completing the square, or the quadratic formula. We can have rational number solutions, fractions, or we can get crazy irrational numbers as our solutions. Sometimes you get crazy numbers as your answer, sometimes you don't. So hopefully the problem sets go well for you this week. And that's the end of Unit 8, folks. So at the end of this week, we're going to be moving on to that next packet that I gave you, which I believe was white. It's been a month since I've seen it, but I believe it's a white packet. So now is also a great time to go dig out that white packet. So next week when we start Unit 9, you'll be ready to go. Bye, guys.